Hello, my name is Luiz Bonino, and this presentation reports the current status of the work on the Fed Digital Object Framework. For the conceptual model part of the framework, the work has also the collaboration of Giancarlo Guizzardi. I assume that you are all familiar with the FAIR principles by now, of course. In RDA, this has been discussed for many years. Of course, to call this framework a FAIR digital object framework, it should be based on the FAIR principles. The FAIR principles gave us a set of requirements, especially when you consider that they target primarily machines. These requirements include that we should have identifiers for both metadata and the objects that they describe, that we needed to separate metadata from other types of objects, that we should have clear and explicit relations between the metadata and the objects that they are describing, and that we should present at least our metadata in a machine actionable format so that machines are able not only to read the metadata content, but also to interpret it and act on the newly acquired knowledge. In FDOF, a FAIR digital object is defined as a sequence of bits that represent a machine actionable informational unit. This means that not all sequences of bits are FDOs, but only those sequences that have an informational value by themselves. So they don't depend on anything else. Just by themselves, they represent some kind of information or can convey information or can produce some information. And that they are machine actionable following the requirements of the FAIR principles. Of course, larger FDOs can be composed of smaller FDOs as long as the smaller FDOs that are part of a larger one have an informational value by themselves. An example would be a repository, which is an FDO by itself, and this repository contains a number of data sets or metadata, whatever the repository contains, which are other FDOs as well. And this should be represented using some kind of containment structure that you can relate one FDO to another one using some specific relations that are relevant according to the situation. The main features of FDOF are that it defines a clear separation between object, identifier, and metadata. It provides a predictable resolution behavior. There is a mechanism to access the object's metadata from the identifiers, from the object's identifier. The framework defines explicit and relations between the metadata and the objects they describe. There is a common metadata presentation format so that machines can read and interpret them, and it provides a typing or characterization system for the objects. Here we have simplified versions of the FDOF conceptual model representing some of its aspects. Given the time, I just selected some that I think that will be more interesting to present here. In this diagram, we have that there are entities that are able to be identified by identifiers of a given type, like PIDs, URIs, etc. Then we have FAIR digital object that's a specialization of this identifiable entity that are not, the FDOs are not only able of being identified by identifiers, but they must be identified by an identifier. And this identifier should not be any kind of identifier, but should be a kind of identifier that presents properties such as global uniqueness, persistency, and resolvability. So if we don't have identifiers, we don't have FDOs. These are absolutely required. Everything should be identified. Here we have the separation between metadata and the objects they describe. Of course, metadata is also another type of FDO. In the conceptual model depicted here in this diagram, we have metadata and ground entity as two specializations of FDO. We use this approach to avoid the infinite recursion that a metadata record as a proper FDO should have its own metadata record, which should have its own metadata record, and so forth. And using this, we can say that regular FDOs must be described by a metadata record, but a given metadata record may not have its own metadata. The typing system of the FDOF provides information about three aspects that can be used to classify a given FDO. The idea here is to provide information about how this object is presented through its encoding format. That's how it's done in a digital environment, so we need to have an encoding environment. Another type of information is what's the role that this object plays as an informational artifact, and this is provided by the informational entity type. And what does the object refer to in the world? To better understand this, just have two very simple examples. Of course, we can elaborate and have more complex with more elements, but just to give an idea, here we have the object X, which has the informational role of an image and is encoded in JPEG. This object refers or represents a party where John and Mary attended. So we have a photo of a party, and then we have John and Mary attending a party, which is an event, and so forth. In another example, we have the object Y, which is a data set encoded in XML and represents gene-diseases relationship. Regarding the FDOF predictable resolution behavior, we have two options. The direct behavior is that the identifier resolves directly to the target FDO. The assumption is that this is the most commonly expected behavior, especially if we already know the object and want to interact with the object repeatedly. Another point is that this direct behavior is equivalent to what's implemented in most current infrastructures like the web, where the URIs are normally used as URLs, meaning that they represent the actual location of the resource. So when you resolve a URI, the identifier, that URI is behaving also as a URL, the location, and then the infrastructure, the web infrastructure, the internet infrastructure, resolves that to the target resource, that's how it's called in the web, using that location. The second behavior is the indirect behavior, where the identifier resolves to something called the FDO identifier record. This identifier record is a small piece of metadata that contains the references to the actual FDO, the FDO's metadata record, and to the characterization, so to the types and type system that we mentioned before. Having the identifier record, the client is able to get information about what type of object this identifier identifies, so what am I dealing with, and also, if it's necessary, how can I get more information? Basically, how can I get metadata about that object following the reference to its metadata records? As said in the previous slide, the identifier record is a type of metadata that contains reference to the actual object, its metadata, records, potentially more than one, and the typing system. Here we have also a fragment of the identifier record in RDF. Thank you for your attention, and if you want to discuss this subject further, you can contact me. In this URL, I'm gradually writing down these ideas about the Diffed Digital Object Framework. As a disclaimer, so don't take that as a set in stone. This is our ongoing work, and the text in this URL is not always up to date, because first I try to work on the concepts and test and discuss with other people. Then once this is a little bit more mature, then I write down. But I'm trying to work on some of these aspects and as quick as possible write them down here to make it available immediately to everybody. Thank you.